Hi guys, here is the third and last day of section 6.4 on simplifying nth root radicals. The first day we did square roots, the second day we did third roots. On day 3 we're going to focus on fourth roots and we're going to do fifth roots as well, okay? And then you'll have today and tomorrow, Wednesday, to do your homework, and then Thursday we'll take a quiz on section 6.4. Okay? All right, here we go. So if we're going to work with fourth root radicals, right? Here is your fourth root symbol. So you have 4 tucked in this little corner as your root, also called the index, all right? This is the fourth root radical symbol. If you're going to work with fourth roots, then you have to know your perfect fourth powers. What are numbers that you can take the fourth root of? So these are your perfect fourth roots. 1 to the fourth, 1. 2 to the fourth, 2 times itself 4 times. 2 times 2 times 2 times 2 is 16. 3 to the fourth, 81. 4 to the fourth, 256. 5 to the fourth, 625. And then you can see that they get pretty darn big. And then remember, this list can just keep on going forever and ever and ever. So these are the numbers that you're going to want to look for when you're taking the fourth root of a number, except we don't really count 1 because if you take the root of them, it doesn't really change anything that we'd be using. All right, so here we go. So look, for example, if I asked you, what is the fourth root of 625? Well, come to your list and look for 625. It's right there. So that means the fourth root of 625, what number times itself 4 times equals 625? It's 5. So the fourth root of 625 is 5. And you can even check that on your calculator. If you went and you want to take the fourth root, right? So I told you have to go to a blank screen, put in 4, the root you want to take, and then you have to go find that weird looking square root that has that X right there. So you can give it any root you want. So if I put the 4 on the screen first and then go get that weird looking square root, it has just given that X value right there a value of 4. So that's the fourth root now. And then I want to do 625, and then you hit enter, and the fourth root of 625 is 5. Perfect. Okay? All right, well, what if I asked you to take the fourth root of 48? Well, if you go to your list, 48 isn't on here. He's somewhere in between 16 and 81, which means you can't take the fourth root of him and get a whole number. Watch, if you tried to take the fourth root of 48, you would get a decimal. Yep, because you can't take the fourth root of 48. 48 is not a perfect fourth power. So that means you're going to have to look for one of these numbers, if there is one, that divides evenly into 48. Well, they get big so fast, 81 won't divide into them, 256 won't, so your only prayer is 16. If 16 doesn't divide evenly into him, then he's already a reduced radical. But 16 does go into 48. So you can split this into the fourth root of 16 times the fourth root of, well, 16 times what gets you 48? 3. So now the fourth root of 16 is 2. And then the fourth root of 3 is your leftover stuck under the radical part. So now when you simplify the fourth root of 48, it becomes 2 times the fourth root of 3. All right, perfect. Okay, well, what about when you take the fourth root of a variable? Well, again, I hope you know after seeing the square roots and the third roots what we do when we take the root of a variable. But here we go. The fourth root of x to the fourth. The fourth root and the fourth power cancel each other out, and it leaves you with just x. So the fourth root of x to the fourth is x. So that means each x to the fourth, you fourth root, will equal in x. So that's your key when you want to take the fourth root of something. You want to see how many x's to the fourth you can break it up into. All right? So look here. Let's say we took the fourth root of x to the fourth. Well, we know the fourth root of x to the fourth is x, right? Perfect. So then what if I asked you to take the fourth root of x to the eighth? Well, the long way is to rewrite this as the fourth root of, how many x's to the fourth can you rewrite x to the eighth as? Well, I can rewrite x to the eighth as x to the fourth times another x to the fourth, because 4 plus 4 is 8. So now I've rewritten x to the eighth as 2 x's to the fourth. So now I can split this into the fourth root of x to the fourth times the fourth root of x to the fourth, and now the fourth root of x to the fourth is x, times the fourth root of x to the fourth is another x, and now x times x is x squared. So that means the fourth root of x to the eighth is equal to x squared. But remember, there's a shorter way to get to that answer. The shortcut says if you want to take the fourth root of x to the eighth, well, then you're going to take the power and divide it by the root. So this will equal x to the power 8 divided by root 4. And what's 8 divided by 4? It's 2. So this equals x squared. So the quickest way to get to your answer is to take your power and divide it by your root. All right, so if I asked you, what's the fourth root of x to the 12th? The long way would be to see how many x's to the fourth you can rewrite x to the 12th as. Or you could just do, it is going to be x to the power 12 divided by root 4. And what's 12 divided by 4? It's x to the third. Done. All right, well, what about the fourth root of x to the 16th? This will equal x to the power 16 divided by root 4, which is x to the 16 divided by 4 is fourth. So it's x to the fourth, right? It's the shortcut is it becomes x to the power divided by root. Okay? All right, perfect. But what happens if the power does not divide by the root? Well, again, you should have seen this with square roots and third roots. There's going to be a leftover variable stuck under the radical. Okay? So look here. What if I asked you to take the fourth root of x to the 7th, right? Well, going with the long way, you would rewrite this as the fourth root of how many x's to the fourth can you rewrite x to the 7th as? Well, I can break him up into an x to the fourth times an x to the, I can't break it up into another fourth because 4 plus 4 is 8, and I'm only trying to get to 7. So then I'd have to rewrite this one as an x to the third as your leftover. So now you would split this as the fourth root of x to the fourth times the fourth root of, I can't break him up anymore because you can't rewrite x to the third as an x to the fourth. So he's the leftover stuck under the radical part. So the fourth root of x to the fourth is x, and then the fourth root of x to the third stays as your leftover stuck under the radical part. So then the fourth root of x to the 7th simplifies to x times the fourth root of x to the third, okay? All right, so what if I said, what's the fourth root of x to the 14th, right? Well, we could try the long way and start breaking him up. Let's do the shortcut. The shortcut would be take the power, 14, and divide it by 4. But 14 doesn't divide by 4. So we're going to break this up into the fourth root of x to the, what's the closest number to 14 without going over that divides by 4? It's 12. So we're going to break him up into x to the 12th times x to the, how many x's are left over to get you back to 14? 2. All right, and then we'll split them. We'll rewrite this as the fourth root of x to the 12th times the fourth root of x squared, right? So he becomes x to the power divided by root, 12 divided by 4 is 3. No more radical. But 2 doesn't divide by 4, right? Because it becomes 1/2. 2 does not divide by 4, and nothing smaller than 2 divides by 4. So he's the leftover stuck under the radical piece. So that means the fourth root of x to the 14th simplifies to x to the third times the fourth root of x squared. Okay, well, look at this one. What if they asked you to take the fourth root of x squared, right? Well, 2 doesn't divide by 4. So I don't want to write it like that and get some fractional exponent. Well, then you would say, okay, what's the closest number to 2 without going over that divides by 4? There isn't any number smaller than 2 that divides by 4. So that means that this is a simplified radical. The 4th root of x squared literally will stay the 4th root of x squared. He's already simplified. Okay. All right, let's put it all together with our 4th roots. All right, let's simplify these expressions. We just have to put that to assume I don't have to worry about any plus or minus signs or absolute values. So just don't worry. Just go with what you know. All right, so what if I asked you to simplify the 4th root of 81, x to the 4th, y to the 7th, z to the 18th? Well, everything is attached by multiplication, right? There's no adding or subtracting, messing this up. So the first thing I like to do is split everything into its own 4th root radical. So I'm going to rewrite this as the 4th root of 81 times the 4th root of x to the 4th times the 4th root of y to the 7th times the 4th root of z to the 18th. I like to separate everything and deal with each one individually. All right, so let's deal with the 4th root of 81 first. The first thing I would do is go to my list of 4th powers and pray that 81 is on there. It is. That means you can take the 4th root of 81 and get a whole number answer. So I don't need to split him up. So I'm going to leave him as the 4th root of 81 right now. You could put the answer, but I'm going to wait. All right. The 4th root of x to the 4th. Does this power 4 divide by 4? Yes, which means you're going to be able to take the 4th root of him and not have to split him up. So again, I'm going to wait until the next step. I'm just going to leave him alone because he's already good to go. If you wanted to put the answer, you could. I'm going to wait. All right, let's go to the 4th root of y to the 7th. Does this power of 7 divide by 4? No. So we're going to have to try to split him up. So we're going to split him up into the 4th root of y to the, what's the closest number to 7 without going over that divides by 4? It's 4. So we're going to rewrite that as y to the 4th. And then we're going to leave the 4th root of y to the, how many y's are left over to get back to 7? Well, this is 4, then 3 would be left over. Okay, let's go to the z's now. What about the 4th root of z to the 18th? Does this power of 18 divide by 4? No. So we're going to have to split him up. What's the closest number to 18 that divides by 4? 16. So we're going to split him as the 4th root of z to the 16th times the 4th root of how many z's are left over? Well, 16 and what get you back to 18? 2. Okay, so the hard part should be over. Now we're going to go through and get rid of all the radicals that can go away and leave the ones that have to stay. All right, what's the 4th root of 81? Well, the 4th root of 81 is 3. So he becomes 3. All right. The 4th root of x to the 4th is x to the 4 divided by 4 is 1, right? That's x to the 1st power. It's just x. All right, look here. The 4th root of y to the 4th, that's going to be 4 divided by 4, which is 1. That's going to be just y. Okay. Now, the 4th root of y to the 3rd. 3 doesn't divide by 4. Nothing smaller than 3 divides by 4. He's your leftover stuck under the radical piece. All right, so he stays. All right, now we go here. The 4th root of z to the 16. 16 divided by 4 is 4. So he's going to become z to the 4th, no more radical. Then you go to the 4th root of z squared. 2 does not divide by 4. Nothing smaller than 2 divides by 4. So he can't be split up. This is your leftover stuck under the radical piece. So the 4th root of z squared stays. All right, now we just multiply whatever's not under a radical together. So 3 times x times y times z to the 4th. That's going to be 3x, y, z to the 4th. And then anything that is under a 4th root radical, we're going to multiply it together and stick it under one 4th root radical. So that's going to be the 4th root of y to the 3rd times z squared. And that is your simplified answer. Okay? All right, let's try one more 4th root. Okay, so what about the 4th root of 48 times x to the 12th times y to the 25th times z to the third. Well, like I said, the first thing I like to do is split it. Give everything its own fourth root radical since everything's attached by multiplication. So I'm going to rewrite this as the fourth root of 48 times the fourth root of x to the 12th times the fourth root of y to the 25th times the fourth root of z to the third. And then I can deal with each fourth root by itself. All right, so let's look at the fourth root of 48 first. So the first thing we're going to do is go to our list of fourth powers and let's look for 48. He's not on there. So either he's an already simplified radical and he will stay the fourth root of 48, or there is a number on this list that will divide evenly into him. And there is. It's 16. So we're going to break him up into the fourth root of 16 times the fourth root of, well, 16 times what gets you 48? 3. Okay, now we're going to go to the fourth root of x to the 12th. Does this power of 12 divide by 4? Yes, which means you can take the fourth root of him and you don't have to split him up. But I'm not going to do it yet, so I'm just going to leave it as the fourth root of x to the 12th. I'll do that when I come back in the next step. If you want to do it now, you can. I'm going to wait. All right, now let's go to the fourth root of 25. Does this power of 25 divide by 4? No. So we're going to have to split him. What's the closest number to 25 without going over that divides by 4? It's 24. So we're going to split him in to the fourth root of y to the 24th times the fourth root of, well, how many y's are left over to get back to 25? Just 1. Because 24 plus 1 get you back to 25. Okay, and now the last one, the fourth root of z to the third. This power of 3 does not divide by 4. The problem is nothing smaller than 3 divides by 4, which means this is already simplified. It cannot be split up. It cannot be taken the fourth root. So we just leave it as the fourth root of z to the third. He's going to forever be stuck under that radical. All right, let's go through now. Let's get rid of the radicals that we can and leave the ones that have to stay. So the fourth root of 16, is 2. Okay, the fourth root of 3 is our leftover stuck under the radical piece. All right, now we go to the fourth root of x to the 12th. X to the power 12 divided by root 4, 12 divided by 4 is 3. So he's going to be x to the third, no more radical. All right, the fourth root of y to the 24th is going to be y to the power 24 divided by root 4 is going to be y to the 24 divided by 4. Y to the 6th, no more radical. All right, well, the fourth root of y, this power of 1 does not divide by 4. And you can't split them into anything smaller than 1 that divides by 4. So this is your leftover stuck under the radical piece. The fourth root of y is going to stay. All right, and then last, the fourth root of z to the third. We already said that this one can't be changed. 3 does not divide by 4, and nothing smaller than 3 divides by 4. So he's just going to be stuck under that radical for good. All right, here we go. Now we're going to clean up. We're going to multiply anything on the outside that is not under a radical anymore. So 2 times x to the third times y to the 6th. And then anything that is still under a fourth root radical, we're going to multiply it together and stick it under 1/4 root. So that's going to be 3 times y times z to the third. And there is your simplified answer. Okay, so that's fourth roots. Now we're going to do fifth roots, and we're going to call it a day. Okay, so if we're going to use fifth roots now, well, here is your fifth root radical symbol, right? When you take the fifth root of something, you're trying to figure out what can you times by itself 5 times to equal what is ever under this symbol, all right? Well, if we're going to work with fifth roots, we have to know our perfect fifth powers. Oh, I didn't fill them in. Oh, I meant to do that to save time. All right, here we go. So 1 to the 5th is 1. 2 to the 5th is 32. 3 to the 5th is 243. 4 to the 5th is 1,024. 5 to the 5th is 3,125. 6 to the 5th power is 7,776. 7 to the 5th is 16,807. 7 times itself 5 times. It's getting pretty big. 8 to the 5th power is 32,768. 9 to the 5th power is 59,049. And then 10 to the 5th should be 100,000. Okay? And then again, the list goes on and on and on. But these are your perfect 5th powers. These are the numbers that you want to look for if you're going to take the 5th root of something. Again, we don't include 1 because he won't change the number that we're using at all. Okay? All right, so for example, if I asked you, what is the 5th root of 7,776? I am literally asking you, what can you times by itself 5 times that will end up equaling 7,776? Well, if you look up at your list, you're going to look for 7,776. So this is right here. So that means the 5th root of 7,776 is 6. That means that if you were to times 6 by itself 5 times, you would end up equaling 7,776. So the answer to this is 6. Okay? And you can even check it on your calculator. The 5th root of 7,776 is 6. Perfect. Okay, well, what if I asked you, what's the 5th root of 128? Well, go up to your list and look for 128. He's not on here. He's somewhere in between 32 and 243, which means either he's already simplified or you can try and find a number on this list that divides evenly into him. So if you try, there's only so many numbers you could try. 32 is the only one because 243 is bigger than 128, so he couldn't possibly divide evenly into it. So if 128 divides by 32, that means we can simplify him. And we can. All right, so that means we can break this up into the 5th root of 32 times the 5th root of, well, 32 times what gets you 128? And that is 4. So now the 5th root of 32 is 2. And the 5th root of 4 is your leftover part. So the 5th root of 128 simplifies to 2 times the 5th root of 4. All right, perfect. All right, well, let's take the 5th root of a variable. Okay, well, the key is going to be that if you take the 5th root of x to the 5th, this 5th root and this power of 5 cancel each other out, and you're just left with x. What can you times by itself 5 times to get you x to the 5th? It's x. X times x times x times x times x is x to the 5th, right? All right, so that means that for each x to the 5th, you 5th root, it will equal an x. So that's going to be your key to taking the 5th root of a variable and exponent, is that you can take the 5th root of every x to the 5th that you can rewrite. All right, so look here. So if I asked you to take the 5th root of x to the 5th, we know the answer to this is x. Okay, so if I asked you to take the 5th root of x to the 10th, the long way would be to rewrite x to the 10th as so many x's to the 5th. So how many x's to the 5th can you rewrite x to the 10th as? Well, I can rewrite them as 1x to the 5th times another x to the 5th, because x to the 5th times x to the 5th is x to the 5 plus 5, it's x to the 10th. So now I can split them up into the 5th root of x to the 5th times the 5th root of x to the 5th, right? So the 5th root of x to the 5th is x, times the 5th root of x to the 5th is another x times x is x squared. So that means the 5th root of x to the 10th is x squared. But that's the long way. The shortcut says that all you have to do is take the power and divide it by the root. So that means the 5th root of x to the 10th should be equal to x to the power 10 divided by root 5. And what is 10 divided by 5? It's 2. So that also gets you x squared. So that's the shortcut when you want to take the 5th root of a exponent and variable. You take the power and you divide it by the root, right? All right, so if you want to take the fifth root of x to the 15th, well, that should equal x to the power 15 divided by 5, because that'll tell you how many x's to the 5th live inside of him. All right, and it's going to be x to the 3rd is your answer. Okay, if I asked you to take the fifth root of x to the 20th, that's going to equal x to the power 20 divided by root 5, and that's going to equal x to the 4th. Perfect. Okay, but like always, what happens if the power does not divide by the root? Well, again, that's just going to mean that there's going to be some leftover variable stuck under that radical. Okay, you're not going to be able to break everything free. All right, so for example, if I asked you to take the fifth root of x to the 6th, right? Well, according to the shortcut, that would be x to the power 6 divided by 5. But 6 doesn't divide by 5, so I don't want to rewrite it like that. So what we're going to have to do is split this. So we're going to rewrite this as the fifth root of how many x's to the 5th can you rewrite x to the 6th as? Well, I can rewrite it as x to the 5th times how many more x's. I can't write another x to the 5th because I'm only trying to make 6. So that would just be a leftover of 1, right? And then you would split it into the fifth root of x to the 5th times the fifth root of x. Well, the fifth root of x to the 5th is x. The fifth root of just x, well, 1 doesn't divide by 5. Nothing smaller than 1 divides by 5, so he's your leftover stuck under the radical. So then that means the fifth root of x to the 6th will simplify to x times the fifth root of x. All right? So again, the shortest way to do this is to figure out what the closest number to 13 without going over is going to be that divides by 5. All right? So again, the fifth root of x to the 13th, that would be x to the power 13 divided by root 5. But 13 doesn't divide by 5, so I don't want to do that. So we're going to split him. We're going to rewrite it as the fifth root of x to the, what's the closest number to 13 without going over that divides by 5? It's 10. So x to the 10th times x to the, how many are left over to get back to 13? 3. So then we can split it. This is going to be the fifth root of x to the 10th times the fifth root of x to the 3rd. So the fifth root of x to the 10th is going to be x to the 10 divided by 5, x squared. No more radical. The fifth root of x to the 3rd is going to be x to the 3 divided by 5. 3 doesn't divide by 5. Nothing smaller than 3 divides by 5. So he's your leftover stuck under the radical piece. So that means the fifth root of x to the 13th is going to equal x squared times the fifth root of x to the 3rd. Okay? All right, well, look here. What if you had the fifth root of x to the 4th? Again, the shortcut says that's going to equal x to the 4 divided by 5. But 4 doesn't divide by 5, so I can't rewrite it like that. So now you're going to ask yourself, what's the closest number to 4 without going over that divides by 5? There isn't anything that's smaller than 4 that divides by 5, which means you're not even able to rewrite him as 1x to the 5th, right? Because he's only an x to the 4th, which means he's already a reduced radical and he's not going to change. The answer to this is the fifth root of x to the 4th. He's already simplified. Okay, let's put it all together. Let's try a couple and be done. Okay, so let's simplify these fifth root radicals. Well, again, the first thing I like to do, since everything is attached by multiplication, is split it. Give everything its own fifth root so we can deal with it one piece at a time. So I'm going to rewrite this as the fifth root of 1024 times the fifth root of x to the 11th times the fifth root of y to the 20th. And then we'll deal with them one at a time. All right, if we're going to take the fifth root of 1024, first thing you should check is if the 1024 is a perfect fifth power. Is he on your list? Is 1024 on this list? Yes. That means the fifth root of 1024 is 4. So that means I'm not going to have to split him or change him. I'm going to be able to take the fifth root of him and get a whole number. I'm just going to wait to the next step. If you want to do it now, please feel free. All right, the fifth root of x to the 11th says that's going to be x to the 11 divided by 5. But 11 doesn't divide by 5. So we're going to try and split him up. What's the closest number to 11 without going over that does divide by 5? 10. So we're going to split him into the 5th root of x to the 10th times the 5th root of how many x's are left over to get back to 11? Just 1. Okay, now we're going to go here. The 5th root of y to the 20th is going to be y to the 20 divided by 5. Does 20 divide by 5? Yes, which means you're going to be able to take the 5th root of it and not have to split it up. So I'm just going to wait till the next step to do that. I'm just going to leave them alone, and I'm going to do it in the next step. But if you want to do it now, go ahead. All right, here we go. So in this step, I should be able to remove all of my 5th root radicals that can go away and leave the ones that have to stay. All right, the 5th root of 1024. We didn't change him because he's a perfect 5th power. The 5th root of 1024 is 4. So I can say 4. Okay. The 5th root of x to the 10th is going to be x to the 10 divided by 5 is 2. So that's x squared. All right, the 5th root of x. Well, remember, 1 does not divide by 5. Nothing smaller than 1 divides by 5. This is my leftover stuck under the radical piece. So the 5th root of x stays. All right, the 5th root of y to the 20th is going to be y to the, does 20 divide by 5? Yes. So it's going to be y to the 20 divided by 5 is 4. So it's y to the 4th, no more radical. All right, now let's clean it up. Let's multiply anything on the outside together. So that's going to be 4x squared times y to the 4th. And then anything that is still under a 5th root radical, we're going to multiply it together and put it under 1/5 root. But there's only one thing left under a 5th root radical, and that is the 5th root of x. So this is your simplified answer. Okay? All right, one more. All right, what if we had the 5th root of 486 times x to the 4th times y to the 32 times z to the 15th, right? Well, the first thing I like to do is split everything and give it its own 5th root radical. So I'm going to rewrite this as the 5th root of 486 times the 5th root of x to the 4th times the 5th root of y to the 32 times the 5th root of z to the 15th. Okay, here we go. Let's deal with them one at a time. Can I take the 5th root of 486 and get a whole number? Let's look at our numbers. Look at your 5th root powers. Look for 486. He is not on there. He's somewhere in between these two, which means he's either already simplified and we can't change him, or some number on this list will divide evenly into him. So 486. Just start dividing him by possibilities on this list. Well, this one's too big, this one's too big. All these ones are too big. The only ones it could be is 243 and 32. So let's take 486 divided by 243. It worked. That's our guy. So we're going to split him up into the 5th root of 243 times the 5th root of, well, 243 times what gets you 486? 2. Okay, he's good to go. All right, let's work on the 5th root of x to the 4th. This is going to be x to the, does 4 divide by 5? No. Can I split this into anything smaller than 4 that will divide by 5? No. So this is already a reduced radical, and you will not be able to split it or change it. He's going to have to stay the 5th root of x to the 4th, and you're not going to be able to break this free. All right, let's go to the next one. The 5th root of y to the 32 is going to be y to the, does 32 divide by 5? No. So we're going to have to split him. We're going to rewrite him as the 5th root of, what's the closest number to 30 with 32 without going over that does divide by 5? It's 30. So we'll rewrite this as y to the 30th times the 5th root of, well, how many y's are left over to get back to 32? 2. All right, and then last, the 5th root of z to the 15th. Can 15 divide by 5? Yes, which means you can take the 5th power of this radical, and we're not going to have to split them. If you want to do it now, go ahead. I'm going to wait until the next step when I do it all together. All right, here we go. In this step, we should be able to get rid of the radicals that can go away and leave the ones that have to stay. All right, what's the 5th root of 243? The 5th root of 243 is 3. And then the fifth root of 2 was our leftover, so he stays. All right, the fifth root of x to the fourth. 4 does not divide by 5. We will not able to split him, so he's going to stay as the fifth root of x to the fourth. Can't help him. All right, the fifth root of y to the 30th is going to be y to the 30 divided by 5 is 6. Perfect. No more radical. All right, the fifth root of y squared. 2 does not divide by 5. Nothing smaller than 2 divides by 5. So he is your leftover, forever stuck under the radical piece. All right, and then last, the fifth root of z to the 15th. 15 divides by 5, so that's going to be z to the 15 divided by 5 is 3. No more radical. All right, now we just clean it up. We multiply anything that's not under a radical together, so that's going to be 3 times y to the 6th times z to the 3rd. 3 times y to the 6th times z to the 3rd. And then anything that is still stuck under a radical, we're going to multiply it together and put it under one fifth root radical. So that's going to be 2 times x to the 4th times y squared. 2 times x to the 4th times y squared. And now this is your simplified radical. Okay? All right, guys, that does it for section 6.4. So like I said, today was on fourth and fifth roots. You're going to have a homework on delta math. I think it'll be a little bit simpler than this. And then you'll have Tuesday and Wednesday to do that assignment. And then on Thursday, we're going to take a quiz on section 6.4 on all of your square roots, third roots, fourth roots, and fifth roots. So please reach out to me if you have any questions or need any help. And we can do a Google Meet if you need one, whatever you need from me. All right, good luck.